Okay guys, in this video we're going to review really quickly the operation of a vector dot product. And so we've seen vector addition, we've seen vector scalar multiplication, and also now we have this third operation that we call a dot product. And so we write it this way: given two vectors u and v, their dot product is given just as a dot here. You think about sometimes as multiplication, but this is actually something quite different. And remember that if we say that u is something that we'll call u1, how about u2 as its components, we'll say v is some other vector v1, v2 as its components. The fact is, when we take u dot v, and that's how we read this here, we just multiply the horizontal components together. So u1, v1, we're going to take that product there and we're just going to add it to u2 times v2, which is the product of the vertical components. And so when you look at it this way, we say that this right here is a dot product, but these right here are multiplication. And I do want to make sure that you know the difference between those there. So with respect to what we get over here, one thing that is worth re-mentioning, is that what you get for a dot product is a scalar. It's a real number. And so we're basically just going to look at finding the dot product, how you do it, and what it represents here. It'll be in the next videos. But looking at these, say like 7 through 13 here, we have to find the dot product of u and v given two vectors. Well, when we write the dot product, let's just say this is number 7 here. Basically what I want to see is that you're writing first of all u dot v, but then right next door we can just multiply our horizontal components. So 7 times -3, and we'll add that to 1 times 2. And you'll notice that I just used the same formula that you're given up over here. And so what we end up with is this -21, I suppose, added to a +2. And we end up with this number -19. So we say that -19 is the dot product of u and v, and that it is a scalar here. Cheers.